Hi, Zoe. Sorry for the delay. It didn't record earlier today, so I'm doing another version of it. I thought I would look at the problem that you were working on. It looks like you got stuck on this number 7. So I thought I would go through this as an example of exponential regression using the TI84s. It looked like you were able to get a lot of the other questions answered. So um, I don't I don't know exactly where it is you're having issues. So I'm just going to go through this one. So let's look at, let me share the problem that I'm looking at here with you. It's the one that was about the personal income. Let's make sure it gets shared. Okay. So this is the one I'm looking at. So it's your number 7. The table is giving years and kind of by the decade, starting in 1955, 65, 75, and so on. And then for each year, they're reporting the total personal income that was earned by people in a certain country. And of course, it's a large amount. So these are in billions of dollars. So in the year 1955, this country's population earned a total of 414 billion dollars in personal income. All right, so they want us to do an exponential function, and they notice that they have us realign our x variable. It says x is the number of years after 1955. So that means we don't put in the entire year for the x values. In the calculator, it goes into list 1. So list 1 and list 2 is what the calculator uses for x and y, or input output. So x has to be realigned to the year 1955. So that means x is 0 in 1955. That's our start year. So instead of 55, 65, 75 on our x values that we're going to type into the calculator, we will type 0, 10, 20, 30, 40, and then there's just a 5-year gap at the back, so 45 here. All right, so I'm going to go to so let me just read through the questions as I may not come back to this screen. So once we have the model, we're going to put the model in. We're going to round our values to 2 decimal or 3 decimal places. But then on part B, when it talks about what will the country's total personal income be in 2005, and then what does the model predict the personal income will, will it reach 22 trillion? Both of those are using the model in its unrounded, most accurate form. So I'm just going to have the calculator store that automatically during the regression command. So let me show you how to do that. So I have taken this table of values. I have already realigned my x values to go 0, 10, 20, 30, 40, and 45. And then the y values are these other numbers over here. So let me go to my calculator here and show you what I've got typed in here. All right, so you can see, oh, just went off, turn back on. All right, so here we've got these are the years after I realigned them to 1955. So basically you just subtract 1955 from each year to get the difference between the year we're in and the original year. And then these were the y values. So I know you know how to do this because you've already done some other regression. So at this point, we're going to do the regression command. So that's going to start from our stats key right here. And when we get in there, editing, of course, is how we put the information in. So when you want to put the information in, you select edit, and that gets you to your table of values. Once you have your table of values, get out of that, you go to stats again, and this time we're going to go over to calculate. And that's where all our regression commands are, starting with number 4. There's linear, quadratic, cubic regression, and so on. We have to go down to the 10th one to find exponential regression, which is what they asked for. So the exponential regression model that they use, they don't have it written here at this point, but this is what it's using. It's going to compute these 2 values. It's going to compute a value for A, and that's going to be approximately close to our initial value where X is 0 in our table. And then B is our constant multiplier. That's going to tell us whether it is increasing or decreasing. If it's bigger than 1, it's increasing. If it's less than 1, it's decreasing. Of course, we can tell from the data itself that it was increasing, but this will be over 1, it'll be 1 point something. All right, and put those 2 together, and that's the curve that approximates that scatter plot. So I'm going to go down to the X. These first 2 are just reminding us that that's where it's storing X and Y is list 1 and list 2, and that is where we typed in our X and Y values. The frequency list is always set on default. We don't ever mess with that one. I am going to stop here and ask it to store the regression equation where it stores the long version of these numbers with all of the decimal points it can calculate. It's going to go ahead and put it together as a function and store it wherever I like. And I'm going to store it in Y1. So, when you go to this button here and you have your functions, put that out in there. I'm going to have it copy that function right there. So if I go back here, I may have to start my command again. Let me go back and get it. Okay, so I'm going to go down here and tell it I want to store the answer in Y1. So I need to get the name of the function stored there. Now, the names of the functions are all collected in the F4 function list. It should look green on your template, but we have to hit the alpha button regardless of what the colors are. So we hit alpha trace, and that gets us the list of our functions. And I'm just going to be boring and select the first one. So that means it's going to calculate the values for A and B using exponential regression. It's going to put the long, more accurate versions of those numbers, assemble them like this, and put it into Y1. So let's calculate and see what we're dealing with. So we hit enter here. All right, so there again, it's showing us what the model is. It's A times B to the power of X. This is, of course, the X up here is what makes it exponential. The A value to like 7 or 8 decimal places, and the B value has even more decimal places. So those are the long versions of the answer. In my math lab, they just want you to type in the answer, the numbers rounded to 3 decimal places, because I think they just want you to show that you have done the procedure. So the A value rounded to 3 decimal places on this problem would be 446 point. Let's see, 1178. So the 7 will round up. 118. We have a trick-or-treater. And then, of course, our dog has to bark at the tree. I'm going to pause for a minute. Guess I'm not going to pause because I can't find it fast enough. So let's get back to share. Oh my gosh. All right, let me get back to the computer view or the calculator view here. All right, so now am rounding the B value. It's 1.0762 rounded to 3 places. The 6 would stay because it's followed by a 2. So 1.076 to the X like that. All right, so that's what you would type into my math lab. I think my math lab already has the Y equals, and you just put that in the box. That was for part A. Now part B, let's see, what was the year it was asking for? It says, I'm just taking a look here. What will the country's total personal income be in 2005? Okay, so at the year 2005, we have to figure out what X value that is. So we have to figure out how many years past 1955 is 2005. I believe that's 50 years, but if you don't know for sure, you can always take the year you're being asked about and subtract the start year. So it tells me 50 years. So X is 50. So since I already have, I guess I didn't show you this before, but once you do the regression, I'm going to hit Y equals, and look, it's in there. It has stored it for us, but it's also put in the whole long version of both of those numbers. So we can use the Y1 as a function to calculate this thing without having to do it by hand. So what we'll do, the main screen here, we're just going to use function notation. And so instead of where we'd normally write f of 50, we're going to write y1 of 50. Okay. Y1 of 50. So alpha F4, you get the Y1 symbol, and then just use your parentheses in the input. And that is going to be our personal income, total personal income earned for the whole country during that year. 17623. I don't know what it's supposed to be rounded to. 0.146. I don't know. But remember, this is in $1 billion. Okay, which means that, yeah. Okay, so I got this from plugging in 50, and that's what I get out here. This is in $1 billion. So that means that, if I look over the decimal place, that's 3 billion, that's 23 billion, 623 billion. When you get up over 1,000 so that you'd have another decimal place, this area here is actually the trillion dollars. So we can call it 17,623 billion. But if I was going to read this number like a standard form number, I would say 17 trillion, 623 billion, 146 million, and just keep going that way. So once you get over 1,000 billion, you're in the trillions area. Now that's important because part C is asking in what year will income be, I think it's either 22 or 23 trillion. Let me take a quick look and see what it says. It says 22 trillion. So part C gives us a, just in words, it says 22 trillion. Okay. So in what year, sorry for my handwriting, will the income be 22 trillion? So remember, this is 17 trillion. So 22 trillion in this function is going to look like 22,000 billion. That's what 22 trillion looks like. So we're looking for where y equals 22,000 because it's in billion dollars. Okay, so we can either take our function, if we're not going to do, we can take this and make it equal 22,000 and solve it using logarithms, but we'd be using the long version of the numbers. I really think in a case like this, to be the most accurate version, we want to go ahead and use our long version of the numbers that are in here. So what I'm going to do is up here where it has to plot, I'm going to turn the plot on. You don't have to do this to do a regression, but since I'm going to use the graph to solve this with an intersection feature. So the dots are the data points that I entered in there in the stats area. The curve is, I'll hit trace. The curve, is actually that function that it calculated for regression and stored into Y1. So we're going to use that curve to make estimates. So if I was in trace, I am in trace right now. See, I could type 50 from this, and it could also, whoops, I'm sorry. Let's try that again. I have to be in, let me see where the window is. I have to make sure my Xmax window is big enough. So I'm going to scooch out my window to the right here by maybe make it go up to 60. And I guess I'll scoot up the top number. Since I'm going to have to look for where y equals 22,000, I would like to go ahead and make this top of the window bigger than that. So I'm going to call it 25,000 just to make sure it's big enough. Okay, so I'm looking out at least 60 this way, and then I'm looking up to 25,000 vertically. Okay, and what I was trying to do earlier, but I didn't have my window set up yet, is where I just used the main screen and typed in Y1 at 50. If I was looking at the graph, I could also hit trace. Now I don't want to be on the plot, so I hit the down arrow to get onto my function. Now I'm on the function. I could just type 50 from here and see how it gives me the same number, 17,623. Okay, so it can compute it on trace, or you can do it from the main screen and not have to worry about your window. But since I'm going to solve this third one graphically rather than algebraically, I want to know where it's going to equal 22,000. So what I'm going to do is I'm going to take and draw a horizontal line on my graph at a height of 22,000 so that all the y values on that horizontal line are 22,000. And where it hits this curve, that's the intersection. So I know that the point on that curve will also have a y value of 22,000. And so then I'm going to look for that point. So to draw a horizontal line, I need a second function. I'm just going to write y equals 22,000. That'll just be a constant, which is a horizontal line. But there goes that line. Every point on that line has a y value of 22,000. So the point on the blue curve that is also on the red curve will also have a y value of 22,000. So I'm going to use the calculation list over trace to find my intersect. And I'm going to run the intersect feature, and it's going to start asking me questions. It's going to look at the two curves that are graphed, and it says, it's asking me a question, is my first curve in this intersection y1 equals that exponential whatever? I'm going to hit enter for yes, enter, yes. Then it's the second curve, that horizontal line, also yes, since that's the other part that forms that intersection. So I'm going to hit enter again. Now the guess would just mean move your cursor closer to the point that you want. That's really just in case there's 2 points showing. It wants to know which one you want to deal with. It wouldn't really matter on this one because there's only 1 point to look for. So I'm just moving it closer over there. Didn't have to be right on it. Hit enter one more time, and now it's going to do its best estimate of the intersection place. So if you can see this very well, if that's at all. But when it has the intersection point, it gives you the coordinates for it down here at the bottom. Of course, the y is 22,000, but this is the number we're interested in. So this means 53.016949 years after 1955. The output or the personal income is 22,000. So this is telling me how many years after 1955. So I'm going to say X, I'm writing on my paper, so I don't have to keep looking at the calculator. 53.0169. Okay. So that's the calculator business. Now, it asked in what year. It didn't say how long will it take. If it said how long will it take, we would just say 81 or 53.01 years. But for which year it is, this is this many years after 1955. And let's think about this. In the instructions, I think it says round up to the next year. The reason why we would always round up, even though this is very, very close to 53, so you would think you would round down. This means whatever 1955 plus 53 is, we have finished that year and we have started into the next year. So we're really into the 54th year when this is going to hit 22,000. So a lot of times when we're asking what year did something happen, if it's an increasing function, if it goes past the decimal point, if it's not a whole number, but it's a whole number plus a decimal point, that decimal point value means we're into the following year. So let's just go and see what that is. So 1955 plus 54, 2009. Okay, so this means in the year 2009, the personal income hit 22,000 right at the beginning of the year, because we weren't very far into the next year. We were only 0.0169 of the way into the 54th year, which is 2009. Okay, so I hope that helped. If it didn't, email me again and maybe we can hop on Zoom or find some way to clear up your questions. So I'm going to go ahead and stop this and hope it continued to record and upload it and get it to you as quickly as I can. Bye-bye.